Today I would like to talk about Solid, which is basically a mnemonic for a couple of principles that are usually followed in object-oriented programming, but not only. So this is what Solid is. And Wikipedia says that it's, like I said, mnemonic acronym for 5 design principles intended to make software design more understandable, flexible, and maintainable. And many of those principles were promoted or even originated from Robert C. Martin, Uncle Bob. Solid states basically some mnemonic behind 5 acronyms, which is SRPO, CPL, SPI, SP, and DIP, which basically means that this is single responsibility, open, closed, list of substitution, interface segregation, and dependency inversion principle. So the title of this presentation is Solid for Dynamic Languages, so maybe it would be good to sort out first what do we mean by dynamic language. And as Wikipedia say, this is a language that basically executes some common programming behaviors, not during a compilation time, but during runtime. So many of those languages are actually dynamically typed, not all of them, but some of them. And the ones that we probably know the most are Python and Ruby. So why this presentation actually makes sense? For me, it might make sense because there are some problems with existing explanations that are present in the web. And one of those reasons is that many of those patterns or principles are described in context of static languages, where interfaces are, where other features of the language are present that may not make sense in context of dynamic language like Ruby or Python. Another reason is that not in every case, but in many cases, there are a lot of impractical examples. I mean, how often do you code animals? Or how many times have you coded shapes in your system? And basically, many of those examples are built around this stuff. Maybe it's easy to comprehend, but then it's harder to apply to your own projects. That's why I think maybe some practical examples would be better fit here. And a lack of pragmatic recommendations. So we know what the principle is. The theory behind this is described, but how do we actually apply it in our everyday work? So this is a problem to actually comprehend it and maybe have some points that you can follow to actually do it effectively. The first one, I'm going one by one here, is single responsibility principle. And again, after Wikipedia, single responsibility principle states that we should have responsibility over a single part of the functionality provided by the software. There should be one. So basically, this is extract from what we have just saw. So there's a responsibility, right? Yeah, it seems a duplicate. So many people just make a shortcut here and say that one class should have only one responsibility. However, Grady Booch, written in the book called Object Solutions 1995, this statement, so that every class should embody only about 3 to 5 distinct responsibilities. So, well, obviously, this is not a statement behind the SRP, but still, there is some conflict here. So, is he right, or is SRP right? Many of you probably are familiar with REPL because we use it every day. REPL basically stands for read, eval, print, loop. Basically, our console, Ruby console, or the same for Python, is actually an example of REPL. So it basically reads your input, evals it, prints the result, and then loops again. So I think there are around 3 responsibilities here. So does REPL follow SRP? And basically, in Solid Deconstruction talk, Kevin Hamley named it after word games. So basically, you can say that REPL is actually interpreting. So interpreting, well, it's just one responsibility, right? And you can actually play those word games without end because, well, you can name many things in many ways. So basically, maybe we should just focus on what the actual responsibility is, or how should we understand it in the context of this thing. So Martin Fowler defines as responsibility as a reason to change, and concludes that a class or module should have one reason to change. And there is an example of it. For instance, he says that content of the report can change, but also how the report looks like can change. And those are two different reasons for change. One is substantive, and the other one is cosmetic. So basically, a class that should have one responsibility means that a class should have only one reason to change. The problem is what the reason is. There was a difference stated in the quote a bit earlier, but how can we make it more abstract? So there is this example of a client class, something that we usually use when we introduce a new API to the project that does not already have a client, or maybe we just use one that was written already. So here is an example in Ruby that actually presents this sort of client that we might implement at some point in time. And we can see that there are like maybe a few responsibilities here. One is when dev get rooms is defined. Basically, our client wraps a call to external API and exposes it as its public interface. In get method, that's in its private interface, we see the symbolized keys. So the symbolized keys basically takes the result of a response. Maybe it's a JSON hash, a JSON originated hash, and then instead of providing hash keys as strings, it transforms them into symbols. And to the bottom of this file, we can see this headers method, and it seems that there is some concept of access token that we should generate for a hotel ID that is provided in a constructor of this class. So basically, what we can see here, this class provides access to REST endpoint or JSON API endpoint, who knows, of a given service. It handles authentication to this API somehow. We don't know how, but it's irrelevant here. And applies some lightweight processing on the response results. So those are three responsibilities. Can we call those responsibilities? So here comes a concept of low coupling and high cohesion. So Uncle Bob again says in one of his articles that basically if we would like to apply SRP, we would like to increase the cohesion between things that change for the same reasons, and we want to decrease the coupling between things that change for different reasons. And how does it apply to a form object? So this is an example in Ruby for a form object. It's overly simplified, but still it should prove the point. So there is a room form. It has a few attributes. It has a persist method that probably should be responsible for defining a logic how this form should be persisted. Probably it will just save a record in the database, but who knows, maybe it will work the other way. But also there is this method called available room types. And this method can be used in a UI to actually present a dropdown of available room types. So the responsibilities of this class are: one, encapsulates logic for persisting its fields, but also it exposes a helper method that will be used on the UI side. So I think that we should now think what is the difference between cohesion and adhesion. So basically, cohesion is where all the parts of the class or structure in given solution are cross-dependent between each other. For instance, this persist method probably will take all the attributes and save them into database. It will bind its responsibility with those attributes. So it's highly cohesive, right? But this extra helper method is adhesive. It's just glued to the class because it has no dependencies on the rest of the class. It might have, but in our example, it did not. So basically, we can just take it away, build another class, build a small collection or small composite that will be provided to the form from the outside, and then it can be used to populate this dropdown, right? So, well, but again, does this class follow SRP or not? So, basically, here we get to the crux. I don't know what does it mean, actually. I need to sort it out. Of the single responsibility principle. And actually, the words in bold are the most important here. So we should gather together the things that change for the same reasons. Not one reason, but for the same reasons, and separate those things that change for different reasons. So why would we like to change this, this helper method? Because we change the amount of options that we can provide to the form, like when somebody is creating a room. And what if we'd like to change the persist method? This will be probably because we would like to change how it's saved into database, for instance. But it's all related to actually creating a room. So probably it's related to the same reason. I mean, same class of reasons how we tend to say. So to sum up SRP, how can we actually pragmatically say if our class follows SRP? And maybe if it doesn't follow, maybe we should apply some technique to make it follow it. First things first, I think I would like to just look at the class and list all the things that the class do. So exposes a method to actually populate some dropdown in the UI. It consists a logic for saving a record in database. Maybe it's a client that actually transforms the output of some wrapped REST endpoint and adds a little bit of authentication to the process. And then ask yourself if it actually does fit together. If it does, maybe it's okay. If it doesn't, maybe it's time to extract something. And identifying if a class is cohesive is one step in this process. Look at your methods, look at how cohesive they are. Can you actually take something out and it will not break your the rest of the code? If this is the case, maybe it should be outside, but maybe it should not. Maybe it changes for the same reason. And then sort out if there is only one class of reasons to change the class. That's what I just said, right? And probably the last part of this sentence is also important. There's one person that can request them. So if you'd like to identify if there is only one class of reasons to change something, then think who might want to request this thing, right? This is basically to prevent coupling between unrelated things and draw boundaries around them. For instance, if somebody would like us to change the amount of options we have in this form, he probably don't want to break the report generation process, right? So if those two things were coupled together in the same class somehow for some reason, and they depend on each other, and then we change this dropdown, and now we break reporting, this is something that probably should not happen, right? So these two concepts should be separated. There should be different responsibility. So if it's hard for you to actually think about if there is a single class of reasons to change a given class or given structure, then maybe ask yourself who will ask for changes there. And after all, be reasonable about it. I mean, all optimizations or preemptive optimizations to a structure to follow some principle might be counterproductive, might increase indirection. That is a usual cost of any kind of refactoring of this kind. And maybe, well, we don't like that. And that's basically for SRP, but the second thing, maybe it is even more important, is open-closed principle. So what open-closed principle is, basically it states that a software entity, instance of method, class, module, maybe a function, should be open for extension, but closed for modification. So its behavior should be extendable without modifying source code. So what does it mean that it should be open for extension? Obviously, we can extend the behavior of a class or whatever it does by just modifying it, but it's closed for modification, so probably this is not the way. We can extend our class by just providing a base class that we can then subclass from and then provide an actual responsibility. It's one option. So there's a base abstract class. We can extend functionality by inheriting. So we do not have a base class per se, but we have a class that we inherit from and change the behavior or extend it or limit it. Who knows? We can wrap it also, right? Obviously, we can just provide some parameters that will allow us to modify the behavior of a class. Those might be just regular parameters, but in this case, we actually mean lambdas or blocks, right, or closures. Basically, something that you can provide to a function or a class and change its behavior from outside. And this is just an example of actual dependency injections, right? So if we inject a dependency from outside, and it can be just an object, but as well you can just provide lambda and control the behavior this way. Okay, so we know how we can extend the class or extend the behavior. So what does it mean that it should be closed for modification? We can modify a class when we fix a bug, but basically responsibility of a class is not fixing a bug, it's a programmer responsibility. So probably it should still play well with what we are after here. Same goes for refactoring. If you are just refactoring a class, you are actually not changing it, right? You are not extending its behavior, nothing like that. So it should be okay. But we can also add something to our class, add something to our structure. That's a modification. It's probably safe, but still. We can remove something from our class. This is probably a breaking change if there are consumers that are actually using this functionality that we have just removed. And obviously, we can change the logic. So the interface stays the same, but we change what it does. And this might be expected or might be unexpected. It's usually expected when it's a bug fix. In the last part, there was a software entity. So this is a subject for this, for which we should apply some ways to the software entity to be extendable, but without modifying it. And this entity, I think it's just an API or a logic of a class or a module or a function. But let's focus on the API first. So I think that we should distinguish between types of API. We've got a private API and public API and something called published API. Private API is usually okay to change. I mean, you can do anything with it because, well, there are no consumers of it beside the class itself or whatever wraps this private API. So you can do anything with it, and it's not actual modification that we are afraid of here. The public API, well, probably you should be cautious when you change it, because if it's public API, then probably it's used somewhere. If it's not, then you should just drop it. And if you change public API, obviously you have to change its usages, especially if the contract that describes how the API should be used changed. If the logic changed, maybe there is nothing to do there, but still. But how does it differ from a published API that you should probably not change? Published API is an API that you have published to the outside world, to the consumers that actually may use it, but you have no control over them. You cannot, obviously you can call them and somehow identify them and say, oh gosh, I just changed my API, you should change your code. But probably this is something that should not happen. So in case of published API, you should be very cautious when making any changes. You can add something, sure. You probably should not remove something. Maybe you can change the logic and they will not notice. But still, this is something that you should be concerned about. So basically, this is the API. Obviously, it can be an API of a class. It can be an API of an object. It can be also an external API, right? REST API, JSON API, GraphQL API, whatever we want here. So, and those APIs are usually published. If you have it in your own infrastructure, if this API is only used to communicate between your services that you have control over, then sure, why not? You can modify it. It's painful, but it's still doable. But if its API is open to the public and you do not have control over those consumers, it's the same as for the API of a class or object. Yeah. So API is on the one side of the equation. On the other side of the equation, there's logic. And before we dive into how does it apply to open-closed principle, there is something called Churn. And if any of you have used it, probably you are aware of the gem that's actually made after this name. Churn is actually some container for butter. It's called maselnica in Polish. I don't know why, but I have asked Linus and Greg today what does it mean, and it means that something is really, well, when you are really tired, it's some tasks start to be churning. I mean, it's something difficult. But without diving into the details of it, there is this Ruby Critic tool that from time to time I use, and you can see that the churn is on the x-axis of this chart. And on the y-axis, there is a complexity, a metric. So basically what churn measures is the amount of changes that happened to a given software entity, be it a class, be it a method, whatever. So you can see that over here, there are like 14 changes to the piece of code that this dot embodies. But the overall complexity of the code that was changed is around 20. So the farther here we are, the more dangerous it might be. So what it might be that we are making a lot of changes in highly complex classes. And why are we making those changes, right? And obviously changes, does it refer to extension somehow? Probably it should. So yeah. So basically, open-close principle is somehow related to SRP. As James Ellis Jones says in one of his articles that I really recommend, they are a really great overview on solid principles, in my opinion. You can see that this OCP is like the single responsibility principle, but SRP is about minimizing the consequences of future changes to your code. But in SRP, you just draw a boundary around the code and encapsulate it. You know that there is if there is just one reason to change or one person that can request a change, and this change is wrapped within one module, then obviously you will need to apply this change only over there. But what's similar here is that you need to make the same guess, right? So you just need to make an educated guess if this something can change in the future, all right? And it continues with that the actual decision that you need to make here is that you need to decide if you are going to what in your module will make you will make abstract and leave to your module consumers to make concrete, he says, and what concrete functionality do you provide to yourself? How much configurable your class should be? I mean, does it make sense to make it configurable at all? So this is an example of a service object that might prove that not always it is reasonable to do so. So it basically delivers some bye-bye email here, deliver farewells. And this class accepts HODL, probably a root or source for guests that those messages should be delivered to. And then if we investigate the call method, it iterates through guests, and for each guest, it uses a mailer to deliver a message called farewell. But those guests are fetched from guest checking out today query object that's executed for given HODL. So there are like two dependencies here, right? There is guest mailer, there's guest checking out today query. Those are concrete dependencies, and obviously, can you make it configurable this way? You cannot. Obviously, you could. Well, probably you could, because you could inherit from it. But is it the best way? Who knows? But basically, this is a warning sign that you have a concrete dependencies in your code. It might not follow OCP. On the other hand, there is this example that I got from Upcase. Also, Upcase have a series on Solid that's really great. They have very practical examples over there, so I cannot recommend you highly enough watching it. Here comes a class, well, printer. That's basically what it does. It's what we can see here. It just accepts an item that probably is a printable item, and depending on its type, it sends it to printer in a form that should be printable. So for text, it's just 2S. For image, it's a file name of an image. For document, it's a formatted version of an image. And then why doesn't it follow OCP? Because if you'd like to add another type of a subject, of an item here, you would need to modify this print method just to plan for it. So it's not open for extension without modifying the class itself. And another example, it might be similar to the one that we have started with, which is deliver farewell service object. There's a class of purchase that exposes a charge user method, and it uses Stripe to charge a user for a given amount of money. And obviously, if you would like to at any point change Stripe to a different payment provider, there's no easy way to do it. Obviously, we can subclass from this class, but still, subclassing from purchase, we should stick with purchase in this case. So does it make sense to make it configurable? This is a question that we need to answer. And to answer this question, we need to understand that, as James Ellis Jones states, the skill here is not just in writing code, which can be extended easily, but also in seeing the opportunity to do so. So the opportunity, there may be a lot of opportunities, but we may need to choose wisely just to not make our code too complex. So a great example of OCP being met in full is a plugin architecture. So the plugin architecture basically depends on contracts that are established between a plugin and the system that embodies it, that actually integrates it. And yeah, so our system that actually handles plugins is open for extension without modification. Just add a new plugin into the equation and it works according to the contract it meets. Dependency injection architecture is obviously another example of pure OCP. It's actually also a technique to achieve it, but in a dependency injected architecture, all the dependencies are somewhere there on a high level of your application, and then they are propagated down and to actually realize some functionality. So you can just change the configuration, and your system will behave differently. So it's configurable without modification in the code. So to make the long story short, we've got a class, and does it meet OCP? I mean, in a pragmatic way. So first, what I recommend is to look at your concrete dependencies. Those are just this query object, maybe this mailer that we have seen in a service object, this Stripe service provider that we have seen in our last example. Is there a likelihood of change here, right? Will it be changed? Or maybe it's very bound to the actual topic of the whole class. For instance, this deliver farewells service object. The farewells should be obviously sent only to guests that are leaving our hotel, right? So should we make it configurable to what guests we should send those? By dependency injection? Probably not. It's deliver farewells. So should we actually make it configurable what mailer we should use? Should we actually make this dependency configurable? Probably not. Are we going to support more payment providers than Stripe? No. Maybe we will. Maybe there is an option for that. And in such case, maybe we would like to make it abstract. And there was this printer example. So this is usually a great example to follow OCP without asking too many questions. If you actually check functionality, probably you should make it abstract. It's also violating tell don't ask principle in some way. So this is a case. This printer case is actually a great example of how not to structure your code. And obviously, again, be reasonable, right? Sometimes even if some of those reasons that might be behind you being encouraged to introduce OCP, they are not present, you might still do it because it will make the whole solution more flexible and maybe even readable and comprehensible. But sometimes, even if some of those conditions are met, maybe it's an overkill to do it now. You can always do it later. I mean, in many cases, you can do it later. It depends, obviously, on many factors. So be reasonable about it. And there is a list of substitution principle, interface segregation principle, and dependency inversion principle that I have not yet talked about, but I'm going to. So before I finish, I don't know if I am behind this statement right now, if I fully agree to it, but those are recommendations. Those are no principles. This is not something that you should follow blindly. This is a recommendation, and in many cases, this is a good one, but not always. So be reasonable about it. And this is another quote from Uncle Bob about taking technical debt. So if you decide not to follow some principle, even though you feel it's applicable, you just need to decide, you just need to be aware that you need to make your code clean, even though you are taking on this technical debt. Because mess is always a loss. So if you are deciding to take on this technical debt, make your code squeaky clean. And for now, there are just two sources here. However, the second one is actually first article from the series of articles that I highly recommend. And the first one I have already recommended a couple of times, which is Solid Deconstruction by Kevin Henley. And yeah, both are really, really great resources. And that's basically it for today. To be continued. Any questions? Yeah, I knew it was comprehensive summary. Okay, thanks guys.